I mean,
It ain't
Monday and Tuesday I could actually work with you online because I'll have internet access. But when I get to Florida on Wednesday, I ain't doing
Jack. Don't call me.
I'm cutting off my damn phone.
Good luck with that, buddy. Honey, you got your phone with you? Because I ain't bringing mine.
My wife's going to be with me, so.
That's what I mean. Since you can use her phone. So yours, man, tucked away in a drawer, let it ring. All right, now what do we have?
Every time I go on vacation, I get some random call. I swear to God, every single time I go on vacation, somebody's in desperate need of something. So I'm cutting my damn phone off.
I don't blame you. That's like when I was had nursing. You only calling me. I charge my phone downstairs, and when I go to bed.
Right.
When I get up, then I'll tend to y'all. But other than that, and I don't have to call you back. Okay, how much you fuss?
Subtraction is exactly the same pattern, except for there's a minus sign between the two top numbers. So just follow the technique.
Subtract 1/3. So you still add?
Nope. You just subtract the two numbers on the top. That's the only thing that changes. The pattern is exactly the same. So I find the bottom number. What's the bottom number?
15, right? Okay. And then you subtract the...
Just do the pattern. Don't subtract anything yet. Just do the pattern.
Okay. 12. Subtract 5. So that'll be 7/15.
There you go.
So you don't subtract until the very end.
You don't subtract until the very... We didn't add to the very end, did we? Right? I'm not trying to be an asshole. I'm really not. I'm really not. I'm just saying.
Right. No, but that's right. But that saying that, it makes sense. You just, that the actual, what they're asking is the very last thing, very last process.
Right. Right. Right.
So you're working it up the same way to get to the actual problem.
Okay. Now, I'm going to show you something else before you do that next question.
Okay, 7:15.
All right. So let's do this.
We're going to
minus.
Oh, you're making one up.
I'm gonna make it. I want to make it so you don't get a negative number. So I had to think about it in my head.
Okay.
All right. Now, instead of doing this, is there any way to make these two numbers look exactly alike? And let me erase this.
Make them alike?
Yeah, just like we did that last question, that last technique. How do I change this 3 and make it a 9?
Times it by 3?
Yeah. So if I'm going to times this by 3, I have to times that by 3, right?
So it'd be, 1/9. No, 3/9.
Okay, so I have 5/9 minus 3. Right? Because the 9 is going to be the same on both of them, right?
Yes.
And then I just multiply the 1 times the 3. You notice I only wrote the 9 once,
yes.
So I would confuse it, right?
Uh-huh.
So what's that equal to then?
2/9.
So like the question you have there, you have a 10 and you have a 5.
Oh.
So we're going to use the same technique because it's going to make the math easier. So I got that minus
4/5. So that would be times 2. So it would be 8/10.
Right? So
then
I have a 10 there. What number goes there?
7 minus 8. That would be 7. It'd be 1/10.
Okay.
But it's not. It's a
negative 1/10.
Right.
Because the bigger number is negative, so the answer has to be negative.
Right. Oh, so that's where even this here comes up. Oh, man, check that out. Wait a minute. Let me write that down when you did that. So that's 5 times. would be 10. That's the same. So it would be 7 minus 8. So we enter negative 1/10. Hot damn. Times 2. Same. Okay.
Okay.
Yes.
Now let's do it with a mixed number. I'm not gonna do that one because I want to show you one.
Okay. It's a different one.
Mm-hmm. And I'll write it the way they're writing it.
Yeah. Don't diffuse me too much, man.
And okay. So that's the original question, right? So I like to stack them, and I have a tendency of just doing that. So I'm gonna have 3 minus 2, and then I have 1/6, and this is 5/12.
So I will need to do, it will be 2 12s, 3 and 2 12s.
So this is
Yeah, just 2 12s.
2 12s.
And so that would be 12 bottom number.
So the bottom number is 12.
And the top number is going to be 10.
No,
No, wait a minute, no.
It's 2 minus 5. I'll show you that step, right? It's 2 minus 5.
Okay, right. And so then it would be 3 12s. So it'd be
What
1 and 3 12s.
What kind of 3 12s?
2. Oh, yeah. Oh, a negative. So it'd be a negative.
It would be a negative.
Where's the but at the 1? From
There's the 1 there. So now I got to do this. I got to do 1 minus 3 12s. Think about it. If I have 3 12s, and if I have 12 12s, and I subtract 3 12s from it, what do you get?
Oh, 12 12s and 3 12s. That would be 12. 9 12s.
And then I got to reduce 9 12s.
It'd be 3 3/4.
And that's your answer. You still follow exactly the same steps, even if you get a negative fraction. That's why I did that to you.
Right. No, that's cool.
Okay, so you ready to try your question now? I don't even know if your question is going to be as hard as that one.
It won't be because there's no negatives in it. None of them have negatives in it.
Oh, you're going to get a negative fraction there. Right there.
Yeah, but I'm talking about the answer. Oh, I see.
That's a positive number. All right.
Let's see what we got. We have 8 and 1/4 minus 3 and 5/12.
So I'm going to grab this. Move it underneath because I'm lazy.
Okay, then I have 12s. So that would be 3, make this 12. Okay, so 60. 8. Am I even writing anywhere close? Nope.
Let me see what.
Wait a minute. Wait. No, 412. 1/3. 5 and 1/3. You go down even. This is what I come up with. Where did I go wrong at?
Uh, 12. That should be 20 instead of 60. That's the problem. When you cross multiply, that should be 20.
How?
What's 4 times 5?
I thought it was 12 times 5 because I changed it.
You look. What's the pattern? It's that times that, which is 12, and then that times that. If you're going to do it that way, and then when you multiply straight across, it's going to be 48 on the bottom here. So you're doing 2 techniques at the same time. That's why I was kind of.
That's what I did.
Yes. So look, is there any way, if those are your 2 fractions,
Right.
is there any way to change this 4 into a 12?
Yes, by 3.
So you have to multiply both the top and the bottom by 3. You need to write that step out. Because you didn't write that step out, that's what screwed you up.
Yeah.
So actually write times 3 on the top, times 3 on the bottom.
Times 3.
Well,
I got
yeah,
then equals 12. So that would be 3, and this would be 12. Okay, then this will still be 60.
No. Are the bottoms the same now? Are the bottoms the same?
Yes.
Then you only write the bottom how many times?
Once.
Once.
This would be 12.
And then you just do the math on the top. That's all you do is just do the math on the top.
So it would be 2. 2 12s.
You have 3 minus 5.
3 minus 2. Yeah, 2.
Okay, maybe we should do a whole bunch of these. Which number is bigger, 5 or 3?
It.
You always write your sign first.
So it would be a negative 2.
Over 12.
Over 12.
Now reduce that. Ignore the sign. Just reduce the 2 12s. What number goes into both 2 and 12?
2.
2.
2 would be 1 6.
And now put the sign in front of it.
Negative 1 6.
That's where that number came from. And now I'm just subtracting 5 and I'm taking 1/6 away.
5. So that would be 4 and 5 6. 4 and 5 6.
You can find the subtraction ones. All right, go ahead and do 9 first. Because they have a bunch of practice ones there that you need to do.
Now we have so
Is that 2.5, 16.5?
yes.
And it's minus?
Yes, sir. Okay, so we will
Right.
14.
Mm-hmm. That's right.
That was easy. Once you look at it. This one. That is 6. Just looking this, I can make this. No. Yes. That'd be 2 6. Correct.
That would be 4 6. Because how do you change the 3 and make it a 6?
Oh, yeah. Okay, I see what you're doing. So that's you times this times 2 times that times 2, so that'd be 4 6.
Mm-hmm.
4 6. Okay. I'm just trying, like I do things in my head. 4 6. So that would be 4 and 5 6.
Don't do it in your head.
I'm not.
Don't do that.
So I'm looking at 1 6. Subtract 2/3. So that would be times 2. So that would be 6. This would be 4. So, so 4 over 6. So that would be 3 6. So 4 and 3 6.
You forgot your negative sign again. Always write the sign of your answer before you do the math. So that when you're looking at those two numbers and you have 1 minus 4, you got to figure out what that sign is first. And a lot of my algebra kids, if they don't listen to me, they always get this stuff wrong.
Because I can't, it's hard. I'm not grasping. I'm looking at, 3.
Look, just look at the numbers. You got 1 and you got 4. Which one's bigger?
The 4.
What sign is in front of the 4?
Negative.
So that has to be the answer. And now do the math. What's 4 minus 1?
4 minus 1 is 3.
That's how you get the answer. You look to see what the sign of the bigger number is. It's always going to be the same sign as your answer. So you write the sign first, and then you do the math. So if I have, what is the sign of that answer first?
Negative.
Now do the math.
It would be 2. Negative 2.
Always write the sign first. Which number's bigger?
10.
What's the sign of the answer?
There's no sign.
If it doesn't have a sign, it's always positive.
Okay.
So my answer is going to be positive, so I'm not going to write a sign there.
Got it.
Then do the math.
Be 5.
You've been doing that since first grade.
Yep.
But it's still the exact same process. So you know how to add and subtract negative numbers.
Yeah.
You've been doing that all of your life. They just
Right.
never explained it to you that way.
No.
So you look at the problem first. You figure out what the sign's going to be.
To the highest number.
To the highest number. Whatever the highest number is, they're always going to have the same sign. So if there's no sign there, there's not going to be any sign there.
Right, because that's a positive number.
So even if I give you something like, what's the sign of that answer?
Ooh, negative.
Now, here's the change. If the signs are the same, you always add.
Yes.
So this is?
3. No.
Add 5.
7. Negative 7.
Always
yeah,
add.
I got it.
Add.
Yes.
Always add.
-7.
If the signs are the same, you always add. Because when you did this, what's the sign of the bigger number there?
Sign really both of them are positive, so you would add, so it'd be 7.
You've been doing that all your life. And I wish they just had explained integers that way, because kids would not be like flipping out when you get a negative number, because they flip out for so long because they can't let go of it.
It's not implanted in you to do that.
Right.
Because they don't,
they do number lines, and then they do all these models, and the kids get even more confused. Just if they're the same, you add them. If they're different, you subtract.
They said, oh, because their kids simplify it. Hey, no. Make it completely understand it, the whole thing in the beginning, then they'll get it.
Right. If you had taught them that when they were learning how to add, they would never have an issue with it, because they wouldn't know any better.
Right. It would just come up automatic. Golly, Dave, that's so right. Okay, wait a minute. We're going back to this one because I ain't done it right. Did I? No. Let me go start over with this one.
I think the negative sign messed you up.
Yeah, so let me just, what was that? 5, 1, 6.
Mm-hmm.
Over 1. Man, this pencil here is going to have that. 1 2/3. So 6 minus thirds. Okay, so it's times 2, so it'll be 6, 4, 6, 6. Be still no 1 minus 4. Larger number is that, so it'll be -3, 6. So I need to
reduce that fraction before you do anything.
it'll be 1/3.
Try it again.
What do you mean? Oh, damn it. It'd be a -1/3, right?
Negative. If you have 3 of them and you need a total of 6, what part of 3 is 6? And what part of 6 is 3? I'm sorry. I should say it the other way. It's not 1/3. What number goes into both?
3 goes into both of them.
So divide 3 by 3. What do you get?
1.
Divide 6 by 3. What do you get?
2. 1/2. Stupid. 1 half. Okay. So it's still a -1/2.
Mm-hmm.
So if I have, this would be 4.
4.
So it'd be 3 1/2.
Right. Right. Because you're subtracting a half away. Right.
Damn, the answer's right there.
Right. It's right there. You just got to get your sign straight.
Yes.
Always do your sign first. Always do your sign first. All right. Oh, man.